All right. Good day, guys. How are you all doing? We'll be talking about aromatic compound, and mostly when you talk about aromatic, you are literally referring to benzene at large. So it's just like talking about benzene and its other derivative of its compound. And most cases, then why it was actually named aromatic was because during the ancient days they thought all these compounds actually some of them have what we call some certain odor. That was why it was being termed aromatic. But later when it is being discovered that it is actually odorless, then but they couldn't change the name again, but you just have to continue using it by what? Under aromatic. So the when you talk about aromatic, we know we are talking about benzene and what? And the derivatives. And literally at large, all of them, they actually belong to a certain particular class of compound which is called the arenes, which is an aromatic hydrocarbon. And there are some most of even drugs that are used nowadays, the modern drugs, so most of them actually have a benzene structure. Example like the Lipitor, this one is actually used to treat low cholesterol. You have Cypressa, you have Navask, which is your amlodipine, which is used to treat high blood pressure. Then you have Cerivent, which is actually a cure for an asthmatic patient. So and the rest of things like that, most of them have carbon structures in them. And there are some certain carbon structure as like the certain class of carbon that we need to get used to, which is the benzene itself and the toluene. We have the autosilane. And what I want to talk about mostly today is the nomenclature of the benzene derivatives. And let's quickly move into that. Now, under the nomenclature of the benzene derivatives, um, we talk about the monosubstituted derivative. That is, if you have a single particular, let's just say a compound or a particular heteroatom or some certain group of atom also, whenever it is a single then, literally benzene would what? Will come as the parent chain, then what the substituent would be named first. Example, you have chlorine at the edge of at the edge there, which is a substituent. When you want to name it, this is automatically what? Chlorobenzene. Then you have NO2. NO2 is coined as nitro. We have nitrobenzene. Then we have ethyl. I think I've explained. If you have not understand how to name a skeletal structure, please go and watch my videos on UPAC nomenclature of skeletal structure of alkane. You would understand better. So this is an ethyl. That's a substituent. So you have ethyl what? Benzene. Then from there, we move on to what we call important. These ones, they are important substituents in aromatic compounds that you need, the monosubstituent that you need to put in your mind, because whenever they appear in a certain particular structure, they need to be called with their name. Are you get what I'm saying? And the moment you go and take one as substituent and start naming, you might make some certain errors. So whenever you see CH3 with a certain benzene structure here, you have this as toluene. And hydroxide with this, you have phenol, alkanol. You have this, you have what? Anisole. And this gives us what? Aniline. Or aniline. Anyone's going to call aniline. So you have NH2 as aniline. Then many more. Let's check out some other ones. Let me draw their structure. Alright, so these are some other ones that we're talking about, like we said now. So these are the ones that you still need to know by heart. You have benzoic acid, you have benzaldehyde. Whenever you see the structure, literally you should know that this is automatically some of the substances that you need to know by heart. So you have acetophenone and you have styrene. So literally these are basically the ones that you need to know by heart. That whenever you see the structure, you should know that this is not substituents and they are literally the basic substitute. They are literally like the main compound structure of a name that is important, that stands alone. One. So let's talk about important things again that we need to understand under benzene structure or naming. Now you see at times benzene in this life is just we call it give and take, or we call it vice versa. At times it might be rich, at times it might be broke. The same thing, the way benzene will shebi oba, at times we shebi eru also. You get my logic? So if that substituent is bigger than the benzene ring, automatically, that's if you have more than 6 carbon atom generated in the particular, let's say the substituent that is the substituent before, the eru, the slave, this is the king. But if the slave has much more carbon atom than the king is 6, this one is much more than it, automatically we treat benzene as a substituent. We treat it as what? As a slave, and we what? We bring this so much on like what? Like the base of it. And literally now, if you look at when you have to count this certain particular carbon structure with the corner piece, 1, 2, 3, 4, 5, 6, then 7, which shows that the carbon atom has surpassed that of what? Benzene. And whenever it surpasses, whenever benzene is treated as substituent, it becomes a phenyl group. Are you get what I'm saying? And they usually indicate at times with pH. That is, you can have something like this pH, then you have 1, 2, 3, stuff like that. So just put pH. You get what I'm saying? So each substituent depends on the amount of substituent that you have there. We only have one here. This is what this will give us one phenyl. Then what is the parent chain? 1, 2, 3, 4, 5, 6, 7. That is what? Heptane. And you have one phenyl what? Heptane. Are you get what I'm saying? So that is the basic for some other ones I need to know. I will talk about the mono like this. So let's go to the what we call di substituted benzene. That's naming two particular categories of the benzene structure. Alright, so sorry I don't have a good handwriting. Please just bear with me. And you having a certain particular aromatic compound. That is, we call, we've talked about mono substituted derivative of benzene. Now when you have a di substituted derivative of benzene, a di substituted, in that terms, if it is a dimethyl, that's a dimethyl structure of benzene. In that process we call them silane. That's the derivative of benzene on its own. So you have three isometric silanes. The first one, we have what we call orthosilane. That's a particular dimethyl processing from 1 to 2. You have what we call metasilane, a particular certain what do they call it? A particular certain dimethyl that process from 1 to 3. You have parasilane, a particular dimethyl that process from 1 to 4. Are you with me? So if you want to name this normally now, you should know that we have either you count from here or you count from here, you're having the same there. 1, 2, 1, 2. You get it? So you have, if you want to name it normal, you're going to be having 1, 2, then you have dimethyl benzene. So whenever you have a dimethyl, you can actually, it's better you utilize the auto. So this one now, you have 1, 2, 3. So this gives us what? 3. You have 1, then 3. So you have 1, 3 dimethyl, then benzene, which you can call metasilane. Then from here you have 1, 2, 3, 4. 1, 2, 3, 4, still the same naming. So you can easily just pick one. So from here you have 1, 4, then dimethyl. You have what? Benzene. So these are their normal naming, but the moment it is a benzene derivative, it is better to just put them straight in their direct isomeric silanes constitutionally. That's literally for only a derivative of benzene of dimethyl or dimethyl. So you see at times the isomers that were being shared to you guys, I told you guys that put them at the back of your mind. Most of them, the moment it does not take the name of benzene itself naturally, it's taking the isometric name. That's the isomers. They usually differ from each other in the position of where the methyl group are going to be, and you can name them in two ways. So the two ways at which we can utilize this is the two ways. Now the first way is that you use auto, meta and para also for them. Are you with me? And why do we do this? The second one, you can use locants. Are you get what I'm saying? So now we use both method when that parent chain is a common name. Now if you look at now, we talked about dimethyl. We said dimethyl could possess a name called silane. Now if you look at now, silane and what? Benzene base, they are both different. But this one now, they are having the same base. Let me just put that with same parent chain. Now, from the point of view, this is a structure of what? Literally here, this is a structure of what? Aniso. When I want to name it normally now, I have 1, I have 2. I'm going to say what? 2, then what? Nitro. What am I going to say? Aniso. Right? 1 to 2, nitro aniso, because I don't count this as a normal substituent. So this is literally an aniso structure. Then this counts as just ordinary 2. You can say that both aniso occurs in both of them. So in that moment, you can use both of them. And at times, you usually use O to signify the auto. So at times, you can say O nitro aniso. So you can say O nitro aniso. You are still on the same page. So look at the other one now. We have meta. Why? This is from 1 to 2. That was why you have utilized as auto, because they have the same name after being named. So this one is from 1 to 3, literally. But we know this is the like a base structure which we call toluene. So from there you count 1, 2, 3. You have 3 there, which is bromine. So you have 3 bromo. What are we going to write there? 3 bromo what? You have toluene. and metal can be introduced with M at times. So this can be known as M bromo toluene. I get what I'm saying. So these ones, they can use you can use both names for them because of what they both end at the same certain depth. But whenever you're talking about dimethyl, you move it to the what the main constituency itself. So at this point now you have parachlorobenzaldehyde, and at that point now since it's para, you have this structure as a respiratory a reference to it. So you have 1, 2, 3, 4. That means you're having what? We have 4 chloro. And what are we going to write? Benzaldehyde. Or we say that what? Para means stands for P. We say P what? Chlorobenzaldehyde. Are we clear? So in our next demo, we'll talk about the we'll talk about mono, we'll talk about talk about the polysubstituted derivative of benzene. Alright guys, let's take some certain them. So whenever you have more than 1, 2, you have 3 upward. Now, in that point, you can't use autometal and para again, not that route. So you can't use autometal and para again because they are not even paraing anything again. So literally now you are just left with locant and understanding the asymmetric constituency that I told you guys is very, very important. So the first step that you need to use in naming more than 3 upward is that you have to identify the parent chain first. And if you are to look at this certain one, the parent chain we have in there is what? Now because of this is not benzene anymore. You can see the asymmetric constituency there. So this is now phenol. So the parent chain here is what? You have phenol. Then the second thing is that you identify and name the substituent. Now you are going to name the substituent starting from the parent chain. So if you have to count from there, I have 1, I have 2, I have 3. So if I have to count those from here, I have 1, I have 2, I have 2. So I can actually count from either of the side. I have 4, then I have 5, 6, then 5 and 6. So now if I want to name this now, the side chain is going to be what? 3, 4 dimethyl dibromo rather. Dibromo. So when you combine with it, say that what assign the locant to each substituent. You have assigned the locant as you can see, the numbers value, then you arrange the substituents alphabetically. So this now gives us what we call 3, 4 dibromo, not bromo. Dibromo. So you have 2 bromo, then what? Phenol. So that is a 3, then 4 dibromophenol. Then the next one, let's check out another one. So from this point, we have this, and naming this one now, we also know that literally this is OH, so this is also a certain compound of phenol. So we have this as phenol, and let's assign our locants. We all know that if you are someone that you are not used to, you have not go through some stages of skeletal structure, counting of alkane and stuff like that, you might find all these things hard. Don't just jump. So if I'm to count from this side 1, 2, 3, I will have my first substituent in 3. If I'm to count from here 1, 2, I will have it on 2. So therefore, I name from the one closer. I have 1, 2, 3, 4, 5, 6. But literally don't forget alphabetically. Bromo is what is actually moving before chloro, B before C. You get my logic? And literally even in the normal heteroatom series. Now you have 5 bromo and 2 chloro, then what? Phenol. Are we there? So this now they can be writing literally normal without drawing the skeletal structure. So this also still stays the same name. Are you getting? So this is a benzyl, this is an aldehyde. So literally we set to the benzene, you have the benzaldehyde. So from here now, we count our structure. You also have 1, 2. You get, so you have 2, and what is the substituent? Methyl. So you have 2 methyl. Then what? Benzaldehyde. So you have benzaldehyde. Are we clear? So these are some certain examples that we could actually initiate ourselves with, and some other aspects of ones that we start moving on with also later on. But I feel like this should be like a basic implementation of aromatic compounds.